We're talking about function operations and composition. And here we have some function composition. Let f of x equal 2x to the negative 1 and g of x equal 2 times x plus 7. Find the domain of the function composition for the following function operations. So we have the function g, and we're going to substitute it into the function f. So the function g here is going to be 2x plus 7. And we're going to take the function and we're going to take the function f, which in this case is 2, and this is raised to the negative 1. So right away off the bat, our function 2x to the negative 1. So we can write that down. I'll come back when I know where the space is. So let's continue working with this one. So anytime we have something written to the negative exponent, we can just move it to the denominator and change the exponent to positive. So this becomes 2 over 2x plus 7. And there's no more math to simplify there. So this function is limited, the domain is limited twice. It's limited by what's in the denominator here. And what's in the denominator here is 2x plus 7 cannot equal 0. Because if that's equal to 0, then the whole thing will be off. So we can subtract 7, and we get 2x is equal to negative 7. Divide by 2. And this says x cannot equal negative 7 over 2. So that's one thing that the domain is limited. Another way that the domain is limited is by the function f of x. F of x says 2x to the negative 1. Well, another way that we can write this is we can write it as 2 over x. So in this case, we also know that x cannot equal 0. So those are two things that limit the domain for part A there. So when we write our domain, we have to take those things into consideration. So the domain is going to be the set of all values such that x belongs to the real numbers, such that x does not equal negative 7 over 2, and x does not equal 0. If we write that in interval notation, we have to have 3 intervals. So in interval notation, we can start at negative infinity, and we can go to negative 7 over 2, not included. Then we want a union, negative 7 over 2. And then we're going to go all the way to 0, not included. And then we'll union, and we'll go from 0 to infinity. So basically, we're just cutting 0 out, and we're cutting negative 7 halves out. The next option problem we have here is we're going to substitute f into g. So we have the function f in this case, which is going to be, I'm going to write this as the fraction form. So we know that f of x is equal to 2x to the negative 1, but I'm going to write this as a fraction of 2 over x. So the next thing, we're going to substitute that in. So 2 over x, and we're going to substitute that into function g. So we're going to say 2 times x plus 7. And we're going to simplify that. 2 times 2 is 4, so we get 4 over x plus 7. So our domain is restricted twice. It's restricted here, x cannot be equal to 0. And it's also restricted here by the same thing, x cannot be equal to 0. So we can write our domain. So the domain is going to be the set of all x values that belong to the real numbers such that x cannot equal 0. And in interval notation, we have to have two intervals, negative infinity to 0, not included, 0 to infinity. And then we have one more example here, c. And we have the function f substituted into f. And we're going to use the example that we had over here where we rewrote 2 over x. So we have the original function, which is 2 over x. And then we're going to take that and we're going to substitute it into the function where we have x in the denominator, and then we have 2 in the numerator. So we substituted that in twice. So we don't like to have this fraction in the denominator. So one way that we can get rid of that is we can multiply by the reciprocal here. So we multiply by x over 2 and multiply by x over 2. So in the denominator, our x's cancel, our x's cancel, and our 2's cancel. And in the numerator, our 2's cancel, and we're actually just left with x. So our final composite function, our domain is not limited at all. However, we do have the function that we wrote down where we have 2 over x, and our domain is limited by the x. So x cannot equal 0. So when we write our domain, it's going to be the same as it was for b. The domain is the set of all x values that belong to the real numbers such that x does not equal 0. Negative infinity to 0, 0 is not included, union, 0 is not included to infinity.